Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to continue with our background in statistics that it's so important for econometrics. In the previous videos, we talked a lot about the normal distribution and then the standard normal distribution. In this video, we're going to add one more distribution, and that is the t-distribution. The idea is that while the standard normal distribution is what you initially always learn in statistics, in econometrics, sometimes things change, and most of the times, especially when you do what we will call and what we will see later on hypothesis testing, the t-distribution is the one that is used instead. So if your question is then, why do we need the t-distribution? The answer to that is all on the variance. The normal distribution works beautifully when there are two things that we know. So normal distribution, we know the mean, and we also know the variance. In particular, the normal distribution assumes that we know exactly how the spread of the data is. So to say this clearly is the same as saying when the variance is known, uncertainty is fully quantified. Variance known, uncertainty fully quantified. That's when the normal distribution is appropriate. Now, in real econometric problems, you never know the true variance. If you think about to the videos that we did together on the statistical properties of the OLS, the third statistical properties gave us exactly an estimator for the variance because we didn't have an actual estimator for the variance. Now, why is this important? Like highlighting the fact that we are estimating it from the data that we use to estimate the coefficients. Because what it means is that the coefficient is estimated, and then the noise around it is also estimated. So we are uncertain about the location of the estimate and also how precise it is. So variance absolutely matters. So if you underestimate the variance, you become overconfident. Now, the thing is, if you ignore uncertainty about the variance, you are treating extreme outcomes also as unlikely, which is something that you shouldn't be doing. Because whenever we'll be doing inferences in econometrics, we're always going to say things like on average. We're never making very precise estimations. So keep in mind, ignoring uncertainty about the variance you treat extreme outcomes as too unlikely. The normal distribution does exactly that. So it assumes the variance is fixed and it's known, but when the variance is estimated, then that assumption is no longer valid. That's why we need the t-distribution to correct for that uncertainty about the variance. So same bell shape, just different uncertainty, and it shows here in the tails, the t-distribution being the one in red here, has thicker tails, and that is a reflection about this uncertainty that is now introduced about the variance and any of the inferences. So fatter tails, the mean is still the same, around 0, and it still has the symmetry property that we saw with the normal distribution. So keep in mind, the fatter tails here, these are the ones that are saying extreme values are treated as more plausible. Okay. Now, we need a way to measure this uncertainty or some sort of a measure for that. This is where degrees of freedom are introduced. Degrees of freedom measure how much independent randomness is left after we estimate parameters. Okay. Parameters. So in simple regressions, for instance, you might remember, or you will see in the future, that you always lose 2 degrees of freedom. And then for multiple regressions, you always need to know how many coefficients you have, because that's going to add to that degrees of freedom. The thing that you all need to remember is that fewer degrees of freedom means that you've got more variance uncertainty, you've got heavier tails, and that you should be more cautious. Hope this was helpful to give an idea of the intuition on why the tails here for the t-distribution are different and why we need the t-distribution. In the next video, we'll see what happens to the t-distribution as the sample size grows, and why and how exactly we're going to use the table of the t-distribution to conduct our hypothesis testing. Thanks for following, and I'll see you in the next video.